Okay, the last video that I want to make in this series is uh, with regard to taking the derivative of the inverse of a function. And the way the formula goes is the derivative of the inverse of a function is the reciprocal of the derivative of the original function evaluated at the inverse. We'll say that again. It's the reciprocal of the derivative of the original function evaluated at the inverse. So let's take a look at what this means. I have two curves on the screen here. One is y equals x squared. Now y equals x squared is not a one-to-one function. It does not pass the horizontal line test. And so if we were looking for the inverse of y equals x squared, we would have to restrict the domain to a set of y values for which the function has no duplicates. And so the way we would do that is just restrict the value to be restrict the x values to be greater than 0, or greater than equal to 0 in this case is also fine. When we restrict the domain of y equals x squared to only have x values greater than or equal to 0, then its inverse would be the function y equals square root of x, or y equals x to the 1/2 power, again for x values greater than or equal to 0. Now you can see that these two functions are reflections of one another over the line y equals x. And we'll just go about, let's take some examples here. The derivative of the original function y equals x squared is 2x. And the derivative of x to the 1/2 is 1 over 2 times the square root of x. So those are the two functions there. Now, if we were to take an x value, for example, at x equals 2 on the curve y equals x squared, that is the point 2 comma 4. When x is 2, y would be 4. If we were to take the derivative at that point, we know that the derivative, or the slope of the tangent line, should be 4. Now, if I was to ask, what is the derivative of the inverse of f of x? Or what is the derivative of the inverse of x squared? Well, let's look for a second at the point on the inverse curve. So if 2, 4 is a point on the curve y equals x squared, then 4 comma 2 is a point on the inverse of x squared. So if I were looking for the slope of the tangent line on the inverse curve at 4 comma 2, and I didn't know what the derivative of the inverse function was, which I do in this case. I know that the inverse function is x to the 1/2, and I know that its derivative is 1 over 2 times the square root of x. But if I didn't know what that inverse function was, and I couldn't find its derivative, then I could ask a question in this way. If I were looking for a derivative along that curve at a particular x value, such as at x equals 4, y equals 2, then the way I would ask that question is to find the derivative of the inverse of f of x at x equals 4. Now some books write it in this way. The inverse, they have the inverse of function f, and finding the derivative of that and evaluated at x equals 4 would be written in this way. So to do that, what you would have to do first of all is on the original function, you would have to find the x value, which gives you a y value of 4. Again, we want 4 on the inverse function, and remember 4 is the y value on the original function. It's the x value on the inverse, it's the y on the original. So we need to find the x coordinate that goes with a y value of 4. In this case it's 2. So we would say f inverse of 4 is 2. And so that would be 1 over the derivative of f inverse of 4, which is 1 over the derivative of f at 2. And since f prime of 2 is 4, we get a derivative of 1/4. So they're almost like reciprocals there. They are reciprocals of each other, not different signs. They're not perpendicular though.